In this video, let us discuss about the data types in C. Data types in C are the keywords that specify the type of the data stored in the memory. For example, so we may be storing some values like 12. So that is integer data type. So if you are storing fractional numbers, for example, 14.5, it is floating point number or decimal number. So if you store a value that is in single quote, it is character. If you are storing a sequence of characters within double quotes, then it is string data type. So likewise, we will be handling different types of data. So the data type specifies the type of data that we store in a variable. For example, here, if you declare a variable x with data type int, that means x is a variable that can store integer values or whole numbers. So the data type in C defines the amount of storage allocated to the variable, how much memory should be allocated to a variable, the values that they can accept, and the set of operations that can be performed on those values. So the data types defines the amount of storage allocated to the variable, the values that they can accept, what is the range of values that they can accept, and the set of operations that can be performed on those values. Data types are used to declare variable as well as functions in C programming. We use data type while declaring a variable as well as declaring functions in C. So we can broadly classify the data types in C into three categories: the primary data type, the derived data type, and the user-defined data type. So the primary data type, it is the built-in data types or the fundamental data types. So these are the fundamental data types in C: char, int, float, and void. So the derived data types are the data types that are derived from this primary or fundamental data types. So they are array, pointer, and function. User-defined data types are enumeration, structure, and union. So let us first discuss about the primary data types or the fundamental data types. So the primary data types or the fundamental data types are the basic data types. They are also known as primitive data types. So these are the fundamental data types in C: character data type, integer data type, floating point data type, and word data type. So character data type, the single character. So the keyword used here is char. Integer, it is all numbers. Keyword is int. Floating point numbers is the fractional numbers. The keyword used is float. Void data type means no data type. So here the keyword is void. So we use void when we declare the function. So we do not use this void along with declaring a variable because it is empty data type or no data type. So before discussing about the fundamental data types or the primary data types, let us see what is a range. So for example, if we are given with a set of values 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, we say that the range of this value is from 0 to 9. So that means the minimum value here is 0 and the maximum value here is 9. So the range is 0 to 9. So this is the case of decimal numbers. So but when we come to the computer understand only binary numbers, that is 0 and 1. So now assume that we have only one bit. So using one bit, we can store only two information. So the first one is 0 and the second one is 1. So we say that the range here is 0 to 1. Now assume that we take two bits together. Using two bits together, we can make four different combinations: 0, 0, 0, 1, 1, 0, and 1, 1. So the first one is 0, 1, 2, and 3. So we say that the range here it is 0 to 3. Now let us take three bits together. Using three bits together, we can have eight different combinations: 0, 0, 001, 010, 011, 100, 101, 110, 111. So the first number is 0, 1, 2, 3, 4, 5, 6, and 7. So these are the decimal equivalent of this binary numbers. So here we say that the range is from 0 to 7. The formula here is, the general formula here is that the range is 0, starting with 0 to 2 raised to n minus 1, where n is the number of bits. Here the number of bits is 3, that means 2 raised to 3, we will get the value 8, 8 minus 1, that is 7. So the upper limit is 7. So this is the case where we assume that our numbers are unsigned numbers. So here we use only positive numbers. Now, if you want to represent signed numbers, that means both negative and positive numbers, we have a different formula. It will be from minus 2 raised to n minus 1 to 2 raised to n minus 1 minus 1. Here again, n is the number of bits. For example, here in this case of 3 bits, n here it is 3. So 2 raised to n minus 1 means 2 raised to 2, 4. This from minus 4 to 2 raised to n minus 1, 4 minus 1, that is 3. So let us see, here it is. Here this number we can take it as minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. So that means the range is from minus 4 to 3. So here we assume that the negative numbers are represented using 2's complement representation. Now let us take the case of 4 bits. So if you have 4 bits, then the range for unsigned numbers will be 0 to 50. So that is 2 raised to 4, 16 minus 1, 15. And if you are using signed numbers, then the range will be from minus 2 raised to n minus 1. So this 2 raised to this 4 minus 1, 3, 2 raised to 3, that is minus 9, to 2 raised to n minus 1 minus 1, 9 minus 1, 8. So the range will be from minus 9 to 8. So now let us discuss about the primary data types, so the fundamental data types. The first one is char. The char is used to store a single character. So here this char can be is divided into two categories. It can be both signed char as well as unsigned char. The memory that it uses is 1 byte. For example, if I declare a variable of type char, so for that variable, 1 byte will be allocated. So char x, for x it is a character variable. So 1 byte of memory will be allocated for the variable x. So here the range in this case of signed characters, 1 byte means it is 8 byte. So in the case of signed characters, it will be from minus 128 to 127. And for unsigned char, it will be from 0 to 255. So you can check using our formula. The format specifies that we use in the case of char data type, it is percentage %C. Now the next one, it is int. So int we can have 3 different categories. First one is the short int and long int. So the difference is in the number of bytes that is allocated. Int data type, it is used for storing whole numbers or integers, and this short and long are size qualifiers. So when we add this short in, the number of bytes allocated will be less, and when we add long in, the number of bytes allocated will be more. So here this how many bytes of memory will be allocated depends on the system that you are using. So if it is a 16-bit computer, then short int will take 1 byte, int will be take 2 byte, and long int will be take 4 byte. And if it is a 32-bit computer, it may be like that. Short int, it is 2 byte, int may be 4 byte, and long int may be 8 byte. So the number of bytes that we allocate to this integer data type, it will depend on the computer that you are using. So based on the 16-bit CPU, here the shorten will take 1 byte. So the range will be minus 128 to 127 for the uh, signed integers. And for int, it will be 2 bytes. So this range will be minus 32,768 to 32,767. So 4 byte, the range will be like this. And again, this all the three can be again divided into unsigned shorten and signed shorten. Similarly, int can be divided into unsigned int and signed int. Long int can be divided into unsigned long int and signed int. So the size allocated will be same for unsigned and signed, but the range will be different. So in the case of unsigned shorten, it is minus 128 to 127. In the case of signed, in the case of signed shorten, it will be minus 128 to 127. In the case of unsigned shorten, it will be 0 to 255, considering the fact that the size will be 1 byte. For signed it will be from minus 32,668 to 32,767. For unsigned it will be 0 to 65,535. So based on this 4 byte, this will be the range for this signed long int and unsigned long int. So this is the format specifiers for unsigned shorten. It will be percentage HU. For signed shorten, it will be percentage HT. Unsigned in will be percentage U and signed in will be percentage D or percentage I. Unsigned long in will be percentage LU and signed in it will be percentage LD or percentage LU. And if you omit this signed, if you just write this shortened or int or long int, it means that it is signed int. So if you want to make the variable unsigned, then you have to explicitly specify the unsigned keyword here. Now we have already seen that the size of integer int or shorten or long int depends on the system that you are using. So if you want to know the size, you can use the size of operator. So printf percentage d size of int. So you will get the size of the integer on your system. How many bytes of memory will be allocated for your system. Similarly, you can see the size of shorten, size of long int. And it is not a guarantee that always the size of shorten will be less than int or the long int will be always greater than int. So what it is guaranteed is that the size of shorten should be less than or equal to size of int and it should be less than or equal to size of long int, and that depends on the system that you are using. The next data type, it is float. Float, it is used for storing decimal numbers or sorry, fractional numbers. For example, 3.14, 5.45, like that. If you want to have a fractional number, if you want to store a fractional number, then you have to use the data type float. So there are three variations of float, that is float, double, and long double. And here again, the size of this will be different. So 4 bytes will be allocated for float and 8 bytes will be allocated for double, and long double will have 12 bytes. So the range will be like this. And again, the precision is also different. So precision means how many number of digits will be there after the decimal point. So in the case of float, it will be 7 digits of precision. And in the case of double, it is 16 digits of precision. And long double, again, it is 19 digits of precision. Here again, it is system dependent how many bytes will be allocated. Based on that bytes, the precision will also change. So the format specifier for float, it is percentage %f. For double, it is percentage LF, small letter L and F. For long double, it is capital letter L and F. So these are the fundamental or the primary data types that is available in our in C programming.